Okay, so hello everybody, thanks for joining the session. And so the paper I'm going to present is titled Bridging the Gap Between the Lab and the Field, Dictator Games and Donations. And this is joined with Xinhua Wang. And so the first thing I'm going to do is to give you a bit of background on what this is about and what's the motivation for this paper. And the first point I have here is that, as you can see on the slide, is that in the last decades, there has been a huge interest in social preference research. And you see that I have social preferences in quotation marks. And that's because somebody might think that social preferences is a really broad term. I mean, in a way, almost any social behavior could be thought of as related to social preferences. And in that sense, there's social preference research in sociology, psychology, management, and so on. But here, when I use the term social preferences, I'm referring to a much more specific line of research originating in experimental and behavioral economics, which have some very specific characteristics, and which I think is one of the most important and influential lines of research in experimental and behavioral economics. And so one of the main characteristics of this line of research is that it has been largely focused on studying behavior in what is known as social preference games. And here, I don't want to spend too much time explaining this because I think you all know what I'm talking about, but let me give you some examples. So these are examples of these social preference games. So we have the dictator game, ultimatum game, public good game, trust game. These are some of the most popular social preference games. And these are basically games that map very closely into game theoretic structures and into game theoretic equilibria. And they are meant to be as context-free as possible, in the sense that they don't incorporate any contextual elements from environments outside of the lab. They map very closely to abstract game theoretic structures. And then typical social preference papers study behavior in this type of games. And then the idea is that these games capture different aspects of social behavior. And so that's basically how it works. And now these games have clearly some good things. One of them is that they can be very easily related to theory, to game theory in particular. Another good thing is that they are very stylized tasks so that everybody can run exactly the same game in an experiment. And then this facilitates that evidence is accumulated very quickly. So these are good things, but they also have some clear problems. And one of the main problems is that these games basically don't exist as such in the world outside the lab. They are very abstract and context-free. And now this raises one crucial question, which is the question of external validity. So basically, to what extent are these games externally valid? Or to what extent does behavior in these games generalize to field environments, to behavior in social environments outside of the lab? And that's what this paper is related to, really, this question of external validity. And now, just a bit more background on external validity. I have just one more slide about this, and then I will move to our research question in this particular paper, but just a bit more background. So the first people to raise the issue of external validity in relation to social preference games in particular were Levitt and List in the year 2007 in a very well-known paper, very widely cited paper. But this is not an empirical paper. So here they did not test for the external validity of these games. This is sort of a theoretical discussion of a number of factors that make it very unlikely that these games have a high degree of external validity. And then the thing is that after this initial seminal paper, there has only been a relatively small number of studies about external validity. So there are some papers about the external validity of games and of social preference games also in particular, but really not that many, especially given how important this topic is, because the relevance of social preference research depends on it, really. There's very little research about it. And now, instead of going into all these specific papers, I'm just going to talk briefly about one more paper that I think summarizes a bit the situation. And this is one of my papers that I published last year with Matteo Galizzi. And in this paper, we do two different things. On the one hand, we do a meta-analysis of previous research. And on the other hand, we do a systematic study where we have people play some games in the lab. And then we have the same people face some field situations outside the lab. And we see whether the games can predict field behavior. And just very briefly about the results of this. So in the meta-analysis part, we conclude that there's no evidence of a substantial degree of external validity. And you see some numbers here in the bracket. So 39.7% of the correlations we had in the meta-analysis were significant. And we think this number is actually inflated because of publication bias. And the average correlation we found in these papers is 0.14. The average correlation between the lab behavior and the field behavior is 0.14, which we consider to be, well, fairly small. And then in the systematic study part of the paper, we found basically no correlations between the games we tested and the field behaviors we tested. And so, like I said, there's only a small number of papers, so more research needs to be done on this for sure. But I think it's fair to say that these games actually have some issues of external validity. And that's more or less my summary of the situation. And now from this, we go to our research question here in this particular paper. And the research question is what you see here. So the question is, can we bridge this gap between the lab and the field? So this lack of a correlation between the lab behavior and the field behavior by introducing contextual elements from the field into the lab games. So one possibility is that the reason why these games don't correlate very well with field behaviors is that they are very artificial and context-free. And then if that's the case, one possible solution is to take these games and incorporate to the games elements from the field, so contextual elements from the field, but in the lab. And then maybe you can construct a game that correlates better with field behavior. And that might be a solution to the problem. And that's what we test in this paper. So to what extent is this possible? To what extent can this be done? Now, to answer this question, we need to focus on specific games and specific field behaviors. And on the side of the games, we focus here completely on the dictator game. The dictator game is one of the most widely used social preference games, and it's arguably the simplest social preference game, and that's why we decided to start here, basically. Probably everybody here knows the dictator game, but just in case, very briefly. So this is a game with 2 players, and player 1 is given an endowment of money by the experimenters. And then this person has to decide how much they want to allocate to the second player. And they keep the rest for themselves. And then the second player just receives the allocation and cannot do anything. And that's basically the dictator game. So now the plan here is to see if we can take the dictator game and incorporate to the game contextual elements that map into some particular field environment, and to see if we can increase the predictive power of the game in relation to field behavior. That's basically the plan. Now for that, we need some target field behaviors that the game might want to predict. And we have for these 2 field situations, and these are 2 naturalistic field situations that we created, and that's our benchmark for field behavior here. The first situation is being solicited for a donation to a charity, as you see in the picture on the slide. Now this picture is not from our study. Unfortunately, we don't have pictures from our study, but that's essentially the situation. So this is a situation where you're walking somewhere on the street, and then somebody approaches you, somebody from a charity approaches you and asks for a donation. And then you can decide whether you want to donate or not and how much you want to donate. And we run this field situation in this location that you see here in the other picture. And this is a big patio inside our university. That's a place where typically students hang out. And they organize here a number of activities. So this would be a place where it's fairly natural to find somebody from a charity doing something. And then we ran this study so that after one of the sessions, we made sure that participants had to walk through this patio, and they found this person collecting money for charity. And that's our first field situation. And well, I didn't say it, but it's here on the slide. In this case, it was a charity dedicated to helping children in disadvantaged situations. It was a very well-known charity. Okay, and then we had a second field situation, which was receiving an email where you can check information about volunteering and charities and show interest in volunteering. So this is a couple of weeks after the experiment. The same people received an email, which was in principle not related to the experiment. And then this email said that there were some volunteering opportunities and that the people could access. And then the email had several links that people could click to check information and to show interest in volunteering. And we basically can have a measure based on clicking behavior and information search behavior. We can have a measure on how much interest people show in volunteering. And that's our second field behavior. So these are the two field behaviors. And now our strategy here is to take the standard dictator game and to try to modify it, including elements that map into the field, to make it more similar to the first field situation. So these two field situations are different, and our target field situation here is the first one. So we're going to try to make the game similar to the first field situation. And then the second one will serve as a comparison with a situation that the games are not really meant to address. Okay, and you will see that this creates an interesting comparison. Okay, so now to try to make the game more similar to the first field situation, we need to focus on some specific differences between the game and this field situation. And for this, we decided to focus on three main aspects in which the standard dictator game differs from our first field situation. And so, of course, here, if you look at the situation in detail, at the field situation in detail, you can see that there's basically an endless number of ways in which this differs from the standard game. And we just picked three. We think these three are three of the most important differences. And these are also three things that have been shown to matter in social preference research. And that's why we focused on these three. So the first one is having a student as a recipient versus having somebody in real need as a recipient. And so in the standard dictator game, the recipient of the money is another student, another lab participant, basically. And in our first field situation, the recipient is somebody in real need. In this case, children in real need. Now, the second difference is giving house money versus giving earned money. So in the standard dictator game, you are assigned some money by the experimenter, and that's the money you have to split. And in our first field situation, the money you give is your own money. So you have to take it out of your own pocket. And this is what we call earned money. And then the third difference we focus on is absence versus presence of face-to-face interaction. In the standard dictator game, there's no face-to-face interaction. In our first field situation, there is face-to-face interaction with the person collecting the money. Okay, so that's it. And now, with these differences in mind, we created a series of 4 games. And well, first of all, as you can see in this picture, this is our lab. And this is where we run all the lab games in the same location, in pretty much same way. And we have 4 games in this study. The first one is the standard dictator game, which we need to compare. The second one is a game that is like the standard dictator game, but we changed the recipient from another student to a charity. And in this case, it was a charity working on medical and humanitarian actions, also a very well-known charity. So basically, you are given some money by the experimenter, and you have to decide how much you want to give to a charity, not to another student. Then we have another game where we have the donation to a charity, but we add to that earned money. And in this case, participants came to the lab, they did a real effort task, and they earned some money in this task. And then that money they earned is the money they had to donate to the charity. And they decided how much they wanted to donate. And then we had a fourth and last game, which has donation to a charity, earned money, and also includes face-to-face interaction. So in this case, participants first earned the money in a real effort task. Then they decided how much they wanted to donate to a charity. But in this case, instead of deciding it on the computer, they had to give the money to a person working for the charity who was standing next to the door of the lab. Okay, so basically, they have to face this person they're giving the money to. So basically, these are the 4 games, and all this happens inside the lab, but it's more and more similar to our first field situation. That's basically the idea. And now the question is, of course, how well do these things correlate? How well do these things predict these 4 different games, our first field situation and our second field situation? Okay. And now just one more thing about the experimental design, and it's this table, which summarizes the structure of the whole study. So let me explain briefly. So as you can see, we divided this into 3 separate sort of independent experiments. And the reason is that it was just impossible to have the same people play these 4 games because the games are very similar. So this just doesn't work. And then we had to split the games in different experiments. We have games 1 and 2 in the first experiment, game 3 in the second experiment, and game 4 in the fourth experiment. So these are different people. Okay? And then, as you can see, in each of the experiments, the people had to do something on 3 different days. There was a first day, and on that day, participants came to the lab and played the games. Then there was a second day, and this was several days later. And on this day, participants came again to the lab to do something that was unrelated to social preferences. And then when the experiment was over, they had to walk through this patio, and they faced the first field situation. And then several weeks later, they received the email, which was the second field situation. Okay? And this was everybody in all the experiments. And another interesting thing here is that in experiments 1 and 3, which are the ones with the games that are most similar and least similar to the field situation, we had a control group. And the control group was people who did not play the games on the first day. So they came to the lab on the first day, but they did something that was different from the social preference games. And the reason to have these control groups is to see if playing the games on the first day had an effect on what people did in the field situations. To control for that, we had these control groups. Okay? And that's it. So that's basically the whole structure of the study. And now let's go to the results. So first I will tell you about the results for the first field situation, and then I will move to the second field situation. And the first thing I have here is just some basic distributions to show you what people did in the field and in the lab. But I will show this very quickly, and then I will move to the main question of whether the games can predict the field. So the first slide I have here, this is the distribution of donations in the first field situation in experiments 1, 2, and 3. And well, basically these are the distributions, and this is fairly typical of distributions of donations. So there's a big spike at 0. In this case, it's about 60%. And this is the people who donate nothing. They decide not to donate. And then the rest of the people donate decreasing amounts, in this case, with a maximum of 5 euros. And that's it. Okay. Now, the second slide I have here is the control conditions. So this is the donations in the first field situation of the people who were in the control conditions. So people who did not play the games in the first session. And as you can see, the distributions look very similar to the other distributions I showed to you. And the statistical tests say that there was no difference between the main conditions and the control conditions. Okay, so basically playing the games on the first day didn't make a big difference in the field behavior. And now here are the distributions of the games. So this is behavior in the 4 different games. And I didn't say it before, but the endowment that people had was always 5 euros. And that's what this always goes up to 5. And now, as you can see, the distribution of behavior in the games was actually quite different. Well, quite different, let's say. It's clearly different. And so if we look at game 1, that's the standard dictator game, the distribution is fairly typical of standard dictator games. So we have a big spike at 0 and another big spike more or less in the middle of the endowment, and then smaller bars in between. Then what happens in the second game is that the distribution becomes much flatter. And then if you look at games 3 and 4, which are the ones that are most similar to the first field situation, you can see that these distributions look more similar to the ones that I just showed you for the field behavior. So you can see this already just by looking at these distributions. And I think that's all I want to say about this. And now let's go to the main question, which is how do these 4 games correlate with the first field behavior? And the table I'm going to show you now is just basic Pearson correlations between the 4 games and the field behavior, the first field behavior. These are the correlations. The stars here are as usual. So 1 star means a significant at 10%, 2 stars 5%, 3 stars 1%. And as you can see, what happens here is that if we look at game 1, which is the standard dictator game, we start with a correlation of 0.21, which is a small to medium correlation, not too high, but there is some correlation. And then as we include the contextual elements, the correlation increases until we get to a correlation of 0.65 in game 4. And 0.65 is a really big correlation. We were actually surprised that we could get to something that high. So by any standards, a correlation of 0.65, that's a really high correlation. So we managed to get to a game that was very predictive of the field behavior. And now an interesting thing here is that the correlation does not increase from game 1 to game 2. It actually decreases slightly, although the change is not significant there. And then there's a big increase from game 1 to game 3, and then a bit more of an increase from game 3 to game 4. Okay, but basically, I think the main pattern here is that we managed to increase, by including the contextual elements, we managed to increase the correlation to something that was really pretty high. And now this is just a different type of analysis of the same thing. This is using Tobit regressions that fit better the nature of the data we have. And I guess the most interesting thing here is the second column. So the second column shows the proportion of variance explained by the different games. And as you can see, it goes from a proportion of 4 variance in the field behavior explained by the different lab games. And as you can see, it goes from a proportion of variance explained of 4% in game 1, the standard dictator game, to a proportion of variance explained of 40%. So that's a really massive change. So we really managed to get to a game that was very predictive of the field behavior. Okay, so there's the first field situation. Now let's look at the second field situation, interest in volunteering. And like I did before, just very quickly, this is just a distribution of behavior in the second field situation in the 3 experiments. And here, I didn't tell you how we constructed this variable, but this is, I don't have time to tell you the detail of this, but this is a variable that captures interest in volunteering. So 0 means no interest in volunteering, and then higher numbers mean more interest in volunteering. So as you can see, the distribution looks actually similar to the one we had for the first field situation. So most people, about 60%, don't have interest in volunteering, and the rest of the people have, well, different amounts of interest, basically. And now to the main question, how do the 4 games correlate with the second field situation, with behavior in the second field situation? And here you have the Pearson correlations. So as you can see here, this looks very different from what we got for the first field situation. So the first difference, there's no stars here. It's not that I forgot the stars, so there's nothing significant here. And so if we look at the numbers, if we look at game 1, we have a correlation of 0.15, and that's actually not that different from what we had with the other field situation. It's basically relatively small correlation between the standard dictator game and behavior in this field situation. Then more or less the same correlation with game 2. And once we go to games 3 and 4, these are the ones where we had the really high correlations with the first field situation. The correlation just drops to 0. Okay, so basically what's going on here is that by introducing contextual elements that map into a specific field situation, we managed to increase a lot the correlation with that field situation, but this didn't increase at all the correlation with a different field situation. This actually even hurt a bit, okay? And then last result I'm gonna show you here is the correlation, oh, sorry, this is just an additional analysis based on negative binomial regressions that shows essentially the same thing, no correlation here. And then the last result I'm going to show you is the correlation between the 2 field situations, and that correlation is basically 0. So we also obtained that the 2 field correlations don't, sorry, the 2 field situations don't correlate with each other. And that's it. So these are all the results. And now just briefly the conclusions. So we found that the standard dictator game, again, shows limited power to explain field behaviors. And we found that it is possible to bridge this gap between the lab and the field by bringing the right contextual elements into the lab. So by bringing the right contextual elements into the lab, we managed to get to a correlation that was really high. So we constructed a game that was really predictive of the field behavior. But you have to be careful with this, because that is only going to work for the specific field situation that you're trying to predict. It will not work in general for any field situation, right? Because different field situations are very different. And now probably one of the same messages here is that context matters a lot. And now this is probably why it might not be a good idea to use context-free games if you want to your results to correlate with field environments, because field environments do have a context, and then context-free games are probably not going to be good at that. And from this, we have a final proposal, which I anticipate is going to be a controversial proposal, but our proposal is that lab experimental paradigms should be more informed by the field behaviors they aim to address. So basically, if you want to have games that say something about particular real-world field environments, then you should make your games more context-specific. Maybe using context-free games is not a good idea, unless you don't care about what happens in field environments, which I think it's usually not the case. So that's it. And then just, well, last slide, just here you have my email. In case somebody wants to talk to me about any of this, I will be very happy to talk about this. So here's my email address, and that's it. Thank you.
Thank you, Daniel. Just on time. Perfect timing. Now we'll have a 5 minutes of Q&A session.
Hi.
Monica, do you have?
Oh, sorry.
Yeah. Should we perhaps write the questions on the chat, or
they can unmute themselves? Yeah.
Okay.
I think it's more practical.
So anyone who has a question, go ahead now.
Hello.
Yeah.
Can I ask something? Hi. Hello. That was a nice talk. It's not so much of a question as a comment that we keep finding that the dictator game does not predict behavior in the field, but the dictator game was not designed to predict behavior in the field. It was designed to test a very specific theory and prove that it doesn't work in all applications. So, you know, when we keep using and saying that, I feel that sometimes we might be hurting the experimental community by saying that we're failing to capture what's out there. Well, this is not always necessarily the case.
So this is a very important question, and in my experience, a very controversial question, because different people have different opinions about this. But what I would say is that if you look at the papers that are published in journals using the dictator game, I think most of them, and virtually all of them, say something about field behavior. When they present the game, when they discuss the results, they want to draw lessons that have an application in the field. So I have seen very few papers, I don't remember any actually, that say, I'm using the dictator game, but I don't want to say anything about any behaviors outside of the lab. There are probably some papers like that, just testing some equilibriums or some theory. But I think most of the time people understand the dictator game, experimental economists, behavioral economists who use them, as something that is saying something about the world outside the lab. And that's why I think these things are important. But I totally agree. If you're sure that you don't want any correlation with the field, then that's fine. So in particular, your example is a very good one. If I'm just interested in testing a completely abstract game theory model, and I don't care about whether this predicts anything outside of the lab, then it's fine. But then I think in that case, you might even wonder, do I need this model that doesn't say anything about behavior outside of the lab? But I think that this is a big discussion anyway.
I agree, it's a big discussion.
Matteo had a question.
Yeah, thank you. It's Matteo speaking. Thank you very much. Very nice presentation. So I have one clarification to ask about the procedure. So how could you ensure that participants in the field were only people from the lab, or that not other people mix with participants in the lab? Could you check this?
Yeah, so this was tricky to organize, but I think we could do that. So the second session was in a different room. It was not our usual lab room, and it was a room that was next to this patio. So we knew that people had to go out and cross this patio, and we had an assistant working for us who was dressed as somebody from the charity. And from the location they were standing, they could see the door of the room. So they basically could see the people who were going out of the room, and then they knew they had to approach those people in particular. And then we let people out every 3 minutes, so that we knew the person was going out of the lab alone. So I mean, still we had a couple of situations where the person went out and then they started talking to somebody they knew. And then in those cases, just they couldn't be approached. But this didn't happen too often. And in general, I think it worked.
And then a more conceptual question or comment. I don't see how you tested the external validity of Dictator game, given that you played only game 4 in the field? So you should have played game 1, right, in the field to have an external validity test of Dictator game.
Well, but game 1 doesn't exist in the field, right? So that's just.
So yeah, that's the point. So what do you mean with external validity? This is really conceptual. That's what I wanted to point it out.
Yeah, but I guess the point here is whether the context-free.
How can you say that? How can you say that the results of Dictator game do not survive outside the lab, given that, as you said, it's almost an impossibility test? So it's we are very much at the core of.
But you want to use the game to predict field behaviors, so then you have to compare the game.
No, but on this I very much agree with the colleague who spoke before. I don't think Dictator game was ever thought to be predictive of charity donation. At least this is my reading. It's predictive of some very fundamental attitude or testing some theory. But this is maybe.
So this again, it's a very controversial topic. I mean, in my experience talking to, because I've been doing research on this for a few years now. And in my experience talking to experimental economists, I think many of them are just protective of their games. And like I said before, if we're honest about this and we read the papers and what people write in the papers, just read an introduction or a conclusion section of a paper using the Dictator game. I think very few papers say, look, I don't care about the real world. I'm just playing an abstract game. If it doesn't correlate with any field behaviors, who cares? Nobody.
But let's put another
sorry,
way.
guys, I'm afraid we have to finish the session.
No, thank you. But it was very interesting. Thank you very much. Thank you very much, Daniel.
I can see that perhaps Elif had has a question. Is it a short one or if it's a longer one?
Guys, with Think Question, we need to move on because we have kind of strict on that.
Okay, so, then I'm sorry, we have to move on. And yes, please send the further questions by emails. Thank you, Daniel, for your presentation. And now we'll move to Janse Mol from Free University of Amsterdam. Janse, are you there?
Yes, I'll share my screen.
And the floor is yours.
Yes, does that work? Can you see my screen? Okay, good. So I will present something with a lot of context, so it's maybe nice to go after Daniel. So this it's a design I'm presenting on a virtual reality experiment on flood preparedness. Let's first talk a little bit about the field. Okay, so the motivation here is a very tough one. So it's this point that economic losses due to natural disasters, they are likely to increase. Right, so it has two main reasons. One is that people like to move to fancy places like beaches, and they build houses there, and the cities grow bigger and all of that. And then adding to that is climate change. So yeah, that results in a growth of economic losses. So there's a couple of things we can do about this, and I'm looking specifically at floods here. So if we're talking about flood preparedness, there are a couple of damage reduction strategies. Now, the first one as a Dutch person that I would think about is building dikes, right? So stopping the flood from coming. So that's a structural measure. It's more a collective thing that you have to build with your whole society. A second one is flood insurance. So you can share the costs of these disasters over a large group of policyholders. So that would also be a way to deal with these losses. And the third one is more individual. So these are called individual flood risk reduction measures. So one example would be to put your house on stilts. It's a very costly thing, but it's also very effective. Well, that way, if the flood hits, your house will still be fine. Now, this is the theme here. So I'm looking at these individual risk reduction measures. There's two ways that you can do this risk reduction. One of them is called self-protection, and basically means you reduce the probability of an event. Now, this is very hard for flooding, but for example, wildfires, it's a possibility, right? So you can burn part of the forest, and then after burning this part of the forest, the probability of a large forest fire decreases. well, this doesn't really work with floods. So here we're looking at the other option, which is called self-insurance. And that basically means you reduce the damage in case of an event. So you cannot really stop the event, but if it hits, you take some measures and then make sure that there's less damage. Now, some of these measures, I explained the house on stilts is very expensive, but a very cheaper way to go is to move your expensive stuff and your electric appliances to a higher floor. And that's a costly measure, but if the flood hits, that would lead to less damage. So this is also how we showed the participants what we're talking about. So indeed, we use context in our game. And these measures, they are cost effective in the long run. I have lots of colleagues who've shown that, but the problem is that the public doesn't take them. So I spent quite some time trying to figure out how we can stimulate this. So that's it's my main research question over the past years, how to increase these self-insurance investments. Now, we looked at several things. The effective insurance, you can have it mandatory, you can have it voluntary. How does that change these investments? Well, we can also have a look at financial incentives. So there's been some work on deductible levels. You could introduce a premium discount. And finally, there's been some talk about mitigation loans. So maybe people don't have the budget to invest, right, to spend this money straight away. But maybe if you spread it over time, that could work. So that's a possibility. But what we're looking at here is really the context. So we will use virtual reality technology to show people what a flood looks like. And then we hope that also kind of helps to increase these self-insurance investments. Now, you may wonder why virtual reality technology. Well, there's a couple of reasons for this. Of course, we first tried the usual suspect, right? So the theoretic stuff, the insurance-related incentives. And now we're going more for the context. And why? Because we did some surveys before on flood preparedness, and we found that one of the important predictors is experience, right? And so there's some more literature about this. So experience, if you already experienced a flood in the past or any other disaster, there's also literature on that. So for example, if you know how high the water can come in your home, yeah, it leads to more preparedness behavior later, right? And the thing is also that, you know, if you experienced it, you know how much damage it could be, which is something that is very hard to imagine if you've never seen it. So that's one reason. And the other one are coping values. Now, this is maybe something I have to explain a little bit. Coping values are a part of protection motivation theory, which is a theory that's been used a lot in the health domain to explain cautionary behavior by patients. So it explains that there's two ways to deal with threats. And one of it is threat appraisal. So it basically translates to risk perception. And the other one are coping values, which kind of describes how people think they can cope with a threat. So it has two components. One is called response efficacy. So if people kind of believe that these measures are effective, and the other one is called self-efficacy. So that's a more subjective feeling of I'm able to do this, right? So I'm able to take those measures. And we found there are very high correlations between those coping values and flood preparedness in the field, so through field surveys. And we think that if we use virtual reality technology, we can show people what a flood looks like. We can also show them, we give them a little bit of this experience, right, without doing all this unethical stuff of breaking dikes. And we can also show them maybe, you know, what it looks like to take these measures and that they are indeed effective. Now, let's first get to the game. So I developed this game in previous papers. It shows a lot of context. So basically, this is first a lab game that we will use as a dependent variable. So people have a house and that it can be flooded. We tell them, and this is the decision screen, or this is the screen that they see when the flood risk result is there. So in this case, the participant, right, their home is right here. And in this case, it's not flooded. And you see all the other blue homes, they are indeed flooded. So that's the result. And the game itself looks like this. So this is the decision screen. So we tell them this is the flood probability. We give them the scenario. In this case, it's 25 years. We tell them the maximum damage, and this is the place where we would use the insurance incentives. And then this is the question we're talking about. So how much do you want to invest to reduce the flood damage? And they have 5 discrete investment options with accompanying damage reduction, which also is based on real data. Now, let's have a look at our design to do this virtual reality experiment. So the idea is that we will contrast a control group, which is basically data we already have. So we did this experiment in August last year with 300 participants, and we have, we measured risk perception and worry with survey questions. Then we had them play this game, and we also asked about, what stuff did you do already at home? Did you, have this valves? Did you move stuff to higher floor and so on? So we have a list of that. We asked the coping values, so whether they feel that these measures are effective or not, and they think they're able to do it. We do some risk and time preferences, only survey questions because there was limited time, and some demographics. So this is the data that we already have. And now we want to contrast this with the VR intervention. So here in the VR intervention, we're planning to do an online selection survey where we already ask about this flood risk perception and worry. So same order as the non-VR sample. Then we will do the intervention. I will show you later what that will look like. We will ask some questions, technical VR questions to check, if they were indeed involved in the game. We check flood risk perception and worry again. So note that this was online before they come to the lab, and this is in the lab straight after the game. They play the flood risk investment game as well, because we know, from the control group what average investment levels we have, so we can compare those, and we ask the same questions. And then we have hypotheses about, between subjects, right? So between the two samples, the non-VR and the VR. So we think that, this intervention will increase investments in this game, and it will also increase the coping values. Then we also have some hypotheses within subjects. So we also think that we may be able to increase the flood risk perception, so especially the water levels that they expect, and maybe the worry as well. And then finally, what we will do is 6 to 8 weeks later, we will survey them again, the same group of respondents. So the 100 people that came to our lab, we'll send them another invite to do an online follow-up. And then we ask again for the flood risk perception, worry, the game, and the measures at home, because it could be that after, seeing all of this VR, they maybe moved some stuff upstairs, right? Or maybe they got some information about how to insure their homes. So we also have some hypotheses about the follow-up, right? So we think that the flood risk investment game shouldn't change. So we hope that it's persistent, right? That it doesn't go down a couple of weeks later. We think that maybe the measures at home, they could increase. That's really field behavior. So I'm not so sure about this, but we hope we can boost this as well, even if it's, only asking for more information. And then finally, we think that the coping values, they should also not go down, right? So that after 6 to 8 weeks, we hope that people still feel that they are able to install these measures and that they think they are effective. So that's the plan. Now, how does it work? So here you see me with the headset. So this is what it will look like in the lab. So we use the Network Institute Tech Labs at our university. We use a head-mounted display, and it's programmed in Unity 3D. And we will pre-register. So if you still have some input, I can edit to that. The data will be on data first. So the data from the last year is already on there, and the code will be on GitHub. Now, what does the VR intervention look like? It has 3 phases. The first phase is a sandbag. So people are really required to physically move the sandbags and to stick them to the walls to protect their home. So it takes a couple of minutes. It's really physical activity that they have to pick it up with the handheld device and move it. In the second phase, they are then protected, by their own work, basically. And they're going inside the home, and they can check what it looks like if the flood rages, the storm rages outside the home. They see maybe a little bit of water. You can see over here close to the windows that there's a little bit of water creeping in, but not too much. And then finally, we bring them to the neighbor's home, and they can check what it looks like if your home is not protected. So there will be water, about 1 meter of water in their homes. They see lots of damage, and we give them a flashlight that they can use to look around, because the electricity is off if your home is flooded. So then we show them the consequences of not taking any measures, right? So this is the plan, and because we wanted to do a registered report about this, is rather a new technology. We want to be very clean about this. So we did a sample size analysis, and for this we had to compute the smallest effect size of interest, right? Because this is quite a costly intervention. So we thought let's calculate, what effect size of interest is, minimum. So if we find this, we should go on with this technology to apply this technology to this field. And if we don't find it, then maybe we should go and do other things, cheaper things maybe. So that's what we computed. So let me walk you through it. So these are the results of the non-VR sample. So these are the 5 investment options. With the accompanying damage reduction that we gave them. And this is how many people chose it. So there's almost 30% in our previous sample that didn't take any measures in our game. So we think that if we can bring this number down, so we basically encourage more people to invest at least something. So that will look like this. So the 28% should go down, and to be on the safe side, we assume that they will pick the lowest number. So they will invest, at least 1,000. So this is the smallest other option. Then we will, the benefits would be that there will be a damage reduction of this amount, because this is based on real numbers. And we think the benefits of this intervention should equal the cost. So what would the cost be? Well, there's about this number of people in high flood risk areas in the Netherlands. If we target 0.1% of that, we target 2,000 homeowners. So, for later, if this all works, that's what we would like to do. So we would target 2,000 homeowners, and the cost of that would be about 30,000 euros. So that would be the cost of a VR intervention. And the benefits, well, if we could bring this 28% down, so we managed to bring it down, then we would have a damage reduction. Say we have 16%, right? So we bring this 28% down with 60% point, and we still target these 2,000 homeowners. To go to the smallest damage reduction, we have this flood probability that's the case at in these areas in the Netherlands, and we talk about 25 years. Then the benefits would be about 30,000 euros, a bit more. So the benefits should at least equal the cost, right? So this 16%, this is a bit of a recap. So we had these costs over here. The benefits, if they are 16% of people go from 0 investment to at least 1,000 investment, 2,000 people, then this is the damage reduction. That would save, the society 30,000 euros, right? So that means we're looking at, we want to find an effect of at least this 16%. Now, if we do a power analysis on the Fisher exact test with the alpha 5% and the power of 95%, we find that we need in 2 unequal groups, 300 in the first group, which we already have, that we have that data. So it means we need at least 93 people in the VR sample. And we have the budget to test up to 130. Practically, I think it should be, we will see how far we get, but we aim for at least 100 subjects in the VR sample and maximum 130. So as a recap, here is the design. We have the representative sample of Dutch homeowners. We have already that data. Then we will invite Amsterdam citizens to the lab because they have travel cost, right? So we cannot get them from all over the Netherlands. And they will do this virtual reality intervention and play the game. And 6 to 8 weeks later, we will ask them some more questions and then see if this VR experience indeed managed to change things over time. So that's the plan. And yeah, I'm happy to take questions. Thank you.
Thank you, Janse. I guess, well, we still have 7 minutes for your presentation, so we can have a bit longer Q&A session.
Yes, nice.
And go ahead, guys, please, with questions if you have any.
There were some questions in the chat, so perhaps the people that did write, I think there was at least one question.
Yes, there is one from Lucas Brown. Maybe
Lucas,
you can read it, Janse, and address it. Yeah.
Yeah, so I think Lucas asked a question. It might be problematic. Your control group is pre-COVID while the treatment group is post-COVID. You have a fair point there. Yes, I think well, if we have some more budget, I can see if we can do like some short post-COVID test as well with the control group. Yeah, that's a good point. It's so the thing is that this design is already from a year ago. It takes quite some time to get the whole VR stuff going, and then we had to wait because the labs are closed now. But you're right. This is a problem, so we might have to check for that. Yeah, good point. And then Unity 3D. Yeah, I'm sorry, I didn't explain that, but that's indeed that's the software that you can use to develop the simulations, the VR simulations, basically. Any other questions?
Okay, it seems like not necessarily. I will ask, well, give one more try. Are there any other questions or comments, maybe?
I think it's very cool. That's my comment.
Thank you. Good to hear. It's also good to hear that I managed to explain this because it's quite a lot, but oh, that's nice.
No, I guess no other questions or comments. Maybe you could write, Janse, maybe you could write your email in the chat.
Yes,
just in case anything else comes up in the meantime.
Yes, feel free to contact me. Also, if you don't like to speak out loud in the Zoom.
And the topic is about what do lab experiments tell us about the real world, the case of lotteries with extreme payoffs. In the study, we conducted a lab experiment where subjects make choices between actual real world lottery tickets. I will briefly, sorry, one more thing. I will tell you overall about the design of the experiment, and then hopefully you'll see how it fits into the external validity area. The design is between subjects, and we have 5 treatments within which we separately manipulate the features that distinguish the situation that the lottery customers face in the actual points of sale from the ones that the subjects face in typical lab experiments. I actually have a quote here from the presenter of this session, as the paper that they wrote, that Daniel wrote with Matteo Galizzi, was a bit of an inspiration for our study as well. The aim of our study is to investigate the behavioral effect of differences between the lab and the field, and what they point in their paper is that the interests that economists have, or perhaps should have, in economic experiments comes mainly from being able to learn something about human behavior beyond the specific games played in the lab. And that's what we actually want to do in this study. Our subjects are rewarded with real lottery tickets. And with this method, we can credibly offer really high payments. I'll show you in a second what these payments are. For this purpose, we use a game multi-multi. This is the second most popular lottery offered by the TS. TS is Totalizator Sportowy, which is a state-owned monopolist of lotteries in Poland. And this multi-multi game is the second after Lotto most popular. We use this particular game and not Lotto because the prices here are fixed. In Lotto, they depend on the amount of people that participate in a game or that win the prize, and in multi-multi, they're all fixed. In this way, we can always offer exactly the same amounts or possible prizes to win. And in our experiment, we focus on decisions that the players of this game actually make. So in the lottery, when they go to the point of sale, they choose from a menu of options, ranging from ones with moderate probability and low payoff to extremely low probability and extremely high payoff. Here is the payoff table that the participants of our experiment of two of the treatments, I'll get to that in a second, saw when they were making the choice, but this is also the same table that the participants of the lottery at the points of sale see and they choose from. So here's they have to choose the quantity, they have to bet on a quantity of numbers from 1 to 10. And then depending on how many of these numbers are drawn, then these are the corresponding prizes. So if someone bets on 10 numbers, and 10 numbers are drawn, they win over 500,000 euros. If just 4 numbers out of these 10 that they chose are matching, they're winning 5 euros and so on. In this game, I don't want to go into the detail of the game itself, but in this game, 20 numbers out of numbers from 1 to 80 are drawn. And then, so out of these 20 numbers that are drawn from 1 to 80, depending on how many numbers the person bets on, 10 or just 1, these are the corresponding prices. So obviously if 20 numbers are drawn and someone bets on just 1 number, the probability is relatively high for this 1 number to be drawn, but also the price is just 10 euros. This menu of options, so from 10 to 1 or from 1 to 10, they vary. We consider it in their riskiness. The expected value is pretty much the same for all of them. It's around 40%. And also the probability of a non-zero payoff for each of these 10 options. It's not the same, but it's within a rather small range. The smallest is when betting on 2 numbers here, the probability of a non-zero payoff is the lowest, it's just 6. And it gets up to 25% for when betting on 1 number and on 4 numbers. But it's in a rather similar range. However, when we look at the standard deviation and the skewness, we can see that as the quantity of numbers chosen increases, the standard deviation, the skewness rather drastically increases as well. And so with this, we consider the higher number of quantities, the higher quantity of numbers chosen to be more risky choices. In the experiments, as I mentioned, we had 5 different treatments, and they range from one being completely analogous to the choice that the lottery participants actually face at the point of sale, to one being a standard hypothetical lab choice between lotteries. Our manipulations are that the participants in our experiment either purchase or choose between the tickets provided to them for free. The table with the payoffs is either displayed just with the payoffs or with the payoffs and probabilities of winning this particular payoffs. The choices are framed either as in real world lotteries or as in standard lab tasks, which are more context free. And the choices of the participants either are or aren't incentivized. So these are manipulations within the treatments. And with this design, we want to basically, well, we want to see the extent of external validity that we can implement in the lab and see how it varies depending on the things that we change, the features that we change in the design. But we also can compare our subjects' behavior to the actual sales data. We obtained the actual sales data from this Totalizator Sportowy, from this lottery monopolist in Poland. We have a 3 months worth of data, more than 1 million observations. And so with this, we can very precisely estimate the actual distribution over the choices that the actual lottery players make. And then we can compare this, and we do that to the choices of the subjects in our experiment, depending on the treatment. And so with this, we can investigate the field lab degree of similarity and their external validity. The timeline of the experiment, the experiment consists of 3 parts, 2 parts and a questionnaire at the end. So first they have to choose whether they want to bet on 1 to 10 numbers, or in the lab treatments, we don't call this choosing a number or choosing a bet of a lottery, which is just we name this betting on choosing option A to J. I'll show you this in a second. And apart from this, we also incentivize their choices and their willingness to pay declaration. We use the Becker-de-Groot-Marshak procedure for this, to actually make them tell us how much this particular choice is worth to them. In the second part, we measure their risk posture with Holt and Laurie. We want to see how predictive this popular measure is of the behavior. And then in the third part, we measure the Big Five with the short version TIPI questionnaire. We also measure risk preferences with Domen et al. Questions, and we check for demographics, social influences, gambling habits, personality traits, this I just mentioned, religious and superstitious beliefs. The experiment was pen and paper, and the payment is determined either by the first or the second part of the experiment. So at the beginning, the participants were told that there will be a random draw, and at the end they will be paid according to their choices, either in part 1 or in part 2. As I mentioned, we have 5 treatments. These are their working names. The first is purchase T. That's because this is the closest to the field. The subjects are given at the beginning, they're endowed with 7.5 euros to start with, and they actually have to purchase the ticket that they choose. The second one, the second treatment, getting farther from the reality, is the choice treatment. They get a show-up fee of 250, and they choose between the tickets. Once they choose one, if the first part is drawn, they will get it for free. So the only difference between the first and the second treatment is that in the first one they have to buy it from their endowment, and in the second one they're getting one for free. The next treatment, a step further, is the same as the choice treatment. However, here in the table, so in the first 2 treatments, the participant just see the payoffs, and in the third one, we also add the probabilities. So apart from seeing the table that I just showed you, or actually I can, so this is the one that they see at the points of sale and in the first 2 treatments, the purchase and choice. This is the table they see in the choice probability treatment. So apart from the prices, they also see the actual probabilities of winning particular prizes. And this is the only difference between this third and the second treatment. Then we move further away to the laboratory, to the lab probability treatment. So the probabilities are displayed, but the choices are framed as standard lab tasks. So in this one, in the whole instruction and the whole questionnaires, the lottery and the lottery tickets are not mentioned. It's just framed as options. And they choose which option they would like to participate in, basically. And then there is the last treatment, hypolab property. It just extended by 1. It's the same as lab probability. However, it's hypothetical. So it's not incentivized. The participants get always 5 euros, and their choices, their choices of the lottery, of the options, are not incentivized in any way. Here is a short summary. So starting again from the one closest to the reality and moving further away. The first 4 are incentivized, only the hypothetical is not. In the the lottery tickets are mentioned in the first 3, and then in the laboratory and hypolaboratory, that lottery tickets are not mentioned, then probabilities provided are not in the first 2 treatments, which is as it is in the points of sale, and then we start providing the probabilities of winning particular prizes. And in the first treatment, the tickets are purchased just as they are in the field, although of course in the field they're using their own money. Here they're using the endowment, which we know might have an effect on the choices, but still it's the closest to the reality that we get here. And then the tickets and the options are chosen. Here are the tables that I already showed you. As I mentioned, they just differ either in the probabilities provided, or whether it's framed as lottery or as an option to choose from. And now going slowly to the results. We had 4 experimental sessions, which were run in August and September last year. Overall, we had 326 observations, and the results can be discussed in terms of the differences between the treatments in quantity of numbers chosen and also their willingness to pay, and that's how I'll proceed with the results. So looking at the quantity of numbers chosen, depending on the treatment, we also added data from the field here, the statistics from the field, so that in the order of the field and getting further from the reality, we can see how the choices differ. And just by this, looking at this descriptive statistics, first of all, we see that as we move further away from the reality, the mean of the quantity of numbers chosen is actually decreasing. It's a little bit different for the hypothetical, but it's really difficult to say that hypothetical is, well, I'll get to that in a second. But anyways, we can see that the bets are actually decreasing with moving further away from the reality. And the biggest difference, just for now visually, we can see that adding probabilities actually reduces the long shot seating as the mean and the median and the mode actually go down. So for the first 3, where the probabilities are not shown, the means are around 7 point something and the median 7.8, the mode is 10. And then as we start adding probabilities of winning particular prizes, all of these 3 measures actually decrease. This can also be seen here on the graph. This is the distribution of the quantity of numbers chosen depending on the treatment. So this is the field, how people choose in the field. And starting from the top 10 numbers and decreasing in the number of quantity of numbers chosen. As we move in the treatments further away from reality, we see that betting on 10 numbers decreases, betting on 1 increases, and well, it varies in between. But this, the graph visually just confirms what I just showed you on the previous table. Now, going to more quantitative measures, we ran a Kruskal-Wallis and multiple other tests. Here you can see the pairwise comparison of neighboring treatments. So we compare field with purchase, purchase with choice, and each pair of neighboring treatments. And once again, we see that adding probabilities makes the difference. So the only significant difference between the neighboring treatments is the one where we start adding probabilities. So when we actually show the participants what is the chance of the prize they're betting on. Here we are comparing pairwise, we do pairwise comparisons with the field data and all of our treatments. Once again, we see that purchase and choice exhibit the highest external validity. They're not significantly different from the choices in the field. And once we start adding probabilities, the differences are significant from the ones that customers make in the points of sale. This treatment effect that I just mentioned, we confirmed them in the ordered logic regression. What we also see from this ordered logic regression is that gambling habits do not make a difference, which was surprising to us. And interestingly, also none of our risk measures seem to have a systematic effect on the choices. So neither Holt and Laurie nor Doman's risk preference question do not really tell us anything. We also see that religious subjects are relatively willing to choose long shot options, so betting on a higher quantity of numbers, so choosing these more risky options. And also all of these findings that I just mentioned, they hold when we exclude subjects, those subjects who either make mistakes in the control questions, and also the results hold when we exclude those who reported a really low willingness to pay for the ticket. So this is just to show you that these results are rather robust. Now moving to the willingness to pay for the tickets by treatment. First, also just descriptive statistics. Sorry, Monica, can you tell me how much time I have left? My timer just stopped.
I think you have as much time as you want because we have quite a lot of time by the end. So don't worry about the time. You have all the time.
All right. Thanks.
But you spoke for 18 minutes now.
Okay, thank you. So moving to the willingness to pay, again, we see that whenever the participants have to purchase the ticket from their endowment, their willingness to pay is lower. And then as we move further from the actual purchase to the choice and to the framing of the experiment of the task as a lab choice, the willingness to pay increases. We confirm this in the pairwise comparisons. So first of all, we see that having the subjects pay the purchase one and the choice treatment, having subjects pay for the ticket reduces the perceived value of the ticket, which is to be expected, but still it is confirmed here. And we also see that the real versus the lab framing also makes a difference. So the real framing are the first two pairs, and then in the first pair we see the comparison between the real and the lab framing, and well, it's the difference is well, it's also visible here. So after seeing all these the treatment effects, we were wondering how can we explain the effect of providing probabilities? Why all these biggest differences come from adding the probabilities to the payoff table? To try to find explanations for that, we ran another experiment where we asked participants, new pool of participants, to estimate probabilities from the same payoff table. I'll show you that in a second. And we also looked at more qualitative features of this first main experiment that we did. Apart from our participants from this first experiment choosing the quantity of numbers or the option they want to bet on, we also asked them which option or which quantity of numbers they consider to be the safest or the riskiest. And we analyzed that. And we also asked them to justify their choices, which we later on categorized, and we also try to get some information from this. So first to this new experiment, estimating probabilities. So our findings of this adding probabilities effect could be explained if the subjects actually overestimated the probabilities of winning specific prizes, conditional on choosing a large quantity of numbers. And then if this was stronger, then if they overestimated the probabilities of winning a small quantity of numbers. So now we ask a new pool of subjects to estimate the probabilities. We show them the same payoff table as they saw as in the first experiment they saw in the purchase and choice treatment. So this one where they just see the payoffs and not the probabilities, and ask them to guess the probabilities of winning different prizes. We asked 129 subjects to guess only the probabilities of the highest prizes in a given column, and 124 to guess the lowest probability in a given column. And first, looking at the upper part of this slide, here are the summary stats of the questions about highest prize probability. We asked them to guess the highest prize probability for one number, so there was just one prize. for 4, 7, and 10 numbers. Here's the median probability estimate. Here's the true probability. And when looking at the median to true ratio, we see that actually the participants, the subjects estimate for the high quantity of numbers, the median to true ratio is actually quite high. So they do quite well at estimating the probability. But as the quantity of numbers decreases, they significantly, I mean, they greatly underestimate the probability of winning any prize. And so this actually tells us quite a lot. It suggests that participants may actually underestimate the probabilities of winning lower prizes, and that's why maybe they be more urged to bet on the higher quantity of numbers when the probabilities are not displayed. And then looking now at the lower part of this slide, where we asked about the lowest prize probability, we asked about the lowest prize for when betting on 3, 6, and 10 numbers. That's because in the true probability for these 3 are actually quite the same. And so we wanted to see how they will differ for the subjects. The relationship here is not monotonic. It's not as visible as it is in the highest prize probability. However, the participants generally underestimated the probability of winning in all 3 cases. So this confirms what we thought, is that for the lower quantity of numbers and also for the lowest prizes, the participants generally underestimate the probabilities of winning respective prizes. Now, looking at the riskiest and safest options, so which options did the participants consider to be riskiest and safest? If the subjects misperceive the probabilities of winning, they can also misjudge which options are risky and which are safe. But in this, we actually see little variance. 46% of subjects agreed that choosing 10 numbers is the riskiest, and 51% agreed that choosing just 1 number is safest, which according to our definitions is correct. However, looking at the distributions of what the—
You have 3 minutes left.
Thank you. Looking at the distributions of the options they considered the safest, we see something interesting here as well. So the purchase starting from the closest to the reality, moving further from the reality, we see that when probabilities are not provided in the first 2, subjects tend to report a relatively higher quantity of numbers as the safest. And when the probabilities start being provided here, suddenly they start reporting a lower quantity of numbers to be the safest, which also might explain, well, we think that it actually explains why adding probabilities changes their choices that much, is that they're actually not aware of what the probabilities are, and the lottery providers might be actually benefiting from this. So which option is judged to be the safest and which is judged to be the riskiest has a significant impact on the quantity of numbers chosen. And the last thing, the justifications, we asked the participants to justify their choices in this first main experiment, about which I was talking about most of the time. Something interesting or maybe insightful that we get from that is that those justifications, including the reference to probabilities of winning, were less often encountered in the treatments without probabilities, and the treatments without the probabilities displayed, subjects didn't mention the probabilities themselves. They were more likely to refer to the number of different prizes in a given column, which is also quite intuitive as well, but it also tells us that simply the lottery players are not using the information that they're not given. So if the lottery provider does not provide them with the probabilities, they will interpret their choices, their possibilities of winning prizes very differently than they would if they had been given more information. To sum up, After comparing our data to actual SAYS data, we find strong evidence for high external validity, but only if the reality is carefully replicated. We also see that when probabilities of winning specific amounts are explicitly provided, choices shift towards option with lower maximum possible payoff and lower payoff variance. Subjects show preference, general preference for long shots. And also interestingly, standard lab measures of risk posture do a rather poor job of explaining their behavior. Thank you. And please ask questions if you have any.
So you can also leave your email on in the box, just
sure,
saying
I will.
for the future reference.
Mm-hmm.
Yeah, so I have one question, if I can ask. Well, more than a question, it's a comment really. So thanks for the presentation. I think you have very interesting results there. And so, but I wonder about your conclusions about external validity, because I mean, you explained it a bit there at the end, but this depends on how you think about external validity, because you only get the external validity once you do pretty much exactly the same type of task, but in the lab. So there, I wonder what are you testing there exactly? So this is, if you do the same thing, but in the lab, then yes, it's externally valid. But once you get into the type of task that is more usual in lab experiments, then it sort of falls apart a bit. So once you get into specific probabilities, which is what you would find in Holt and Lowry tasks, and in usual tasks used to measure risk preferences, then it sort of falls apart, and you actually have the Holt and Lowry task. And based on what you said, I understand this doesn't correlate very well.
Not at all, actually.
So then what's the sort of the take-home message about external validity? Should we change the lab measures we use to measure risk preferences?
Well, that's one thing. So first of all, the Holt and Lowry, for example, is widely used, and it measures the risk preferences in nearly, well, a lot of experiments. And then we actually see that when we compare that to the choices, the risk choices that the participants actually make in real life, there is no correlation in that. So, I mean, perhaps why are we using this that much and generalizing it to a lot of cases when we see that the risk preferences in this task of the same participants in the task concerning risk choices that they make in real world don't really correlate with each other? Then what does it measure? And then about the external validity itself is that, well, we also run these two treatments that we did. Of course, one was hypothetical, but one was framed as a standard lab task. This is also often used. I mean, we use a lot of context-free lotteries in the lab experiments, and then we see that this doesn't really get close to the choices that the participants or the people make in real life. So if we do this a lot in the lab and then publish works about that and say how people behave, and then we see that it really is just one feature missing from the reality, and the results don't correlate that much to the real choices. So I think the main message here is that if we want to have high external validity of our studies, which I think we should, if we want to say something about people's behavior in the real world, then doing things as most of us are doing right now in the lab is not really doing a great job.
Yeah, and if I might add one thing to that, I'm partly saying this because some people, when they see that some experimental measure doesn't correlate with field behavior, then the reaction is, oh, lab experiments are rubbish. We should not do lab experiments. We should do field experiments. But I think your data, and also my data to some extent, are saying, well, maybe we should do a different type of lab experiments.
Yeah,
but you can actually have lab experiments that correlate with field behavior. It's just you have to be careful about what you do in the lab.
Exactly, and I think this is the main message that we want to give here.
Okay, thank you.
Yeah, I was kind of, I wouldn't say adding on that, but I find what you presented interesting, and I found what Daniel presented interesting. And I guess kind of the intersection, or the next step in your case would be, okay, so we found that they predicted poorly, so how can we change, the lab experiment in a way that, they can predict more? And this is why I liked Daniel's presentation to some extent, even though I found some points controversial, but I found it still very interesting. So I think that could be also your next step, right, Joanna?
Sure.
Is this what you were thinking? Or,
yeah, well, I'm actually writing a project grant, working on a project grant right now, a new paper where I want to investigate this more deeply.